What questions did you have? Okay. Number 29.
Number 37.
37
Number 49.
and 49.
49 is one of my questions.
Does anyone else have any other questions on the 11-1 homework?
I would have 49 and 53.
53. So we have 3 minutes before class starts. So I'm going to go ahead and just kind of highlight the ones we're going to go over if anyone wants to add any to them. We'll give everyone 1 more minute. Permutation?
Yeah.
That's the factorial button. The permutation and combination are right here. So you actually have to hit second or shift, yeah. And so yours will work where you would hit 4P2. But you'd have to hit 4 first, yeah.
And then the board.
And then 2. Yeah, so you have to hit 4. No, that's fine. It takes some practice, and that's why getting comfortable, bringing your calculators class can be beneficial. You can get comfortable with it versus outside of class. 4 permutation 2 is 12, but that's not quite the answer. Okay, so the first problem we're going to look on 11-1 is number 29, and some of you guys might have issues with this one. When you try to do 14 permutation 3, your calculator might give you an error because it's just a really large number. Some calculators, if you put it all in like parentheses, if you put 4 permutation 2 divided by 14 permutation 3, hit enter, it might handle it better than 14 permutation 3, but it's going to be a really large number in the denominator, making your number overall very small. Right, so let's look at calculating this. For permutation 12, get a little smaller there, would be 4 factorial over 4 minus 2 factorial, right? Which would be 4 times 3 times 2 factorial over 2 factorial, which is just 4 times 3. That's the numerator. The denominator, 14 permutation 3, so I would write that as 14 factorial divided by 14 minus 3 factorial. That, what?
So that's how you're breaking it down?
Yes.
Do we need to know how to break that down or just know how to enter it in the calculator?
If your calculator can handle it, you know how to enter in your calculator. If it can't, then you'll need to be able to break it down. So n permutation r is n factorial divided by n minus r quantity factorial. So this is going to be 14 times 13 times 12 times 11 factorial over 11 factorial. And the 11 factorials cancel, and I'm left with 14 times 13 times 12, oops. No, yeah, that's right. Right? 14 minus 3 is 11. So I know on the denominator I have 11 factorial, so I only need 11 factorial in the numerator. So 14, 13, 12, 11, I can cut it off that. I don't have to plug in 14 factorial in my calculator divided by 11 factorial. If you do, it's the same thing as taking 14 times 13 times 12. So more continuing on, the numerator is 4 times 3, which is 12. Which is, I can cancel, since it's all being multiplied together, I get 1 over, what's 14 times 13? Huh?
I don't know.
182. So that would be our answer there, 1 over 182.
Is it okay if we have it in decimal form? I think that's what's in the back of the book.
Yeah, that's fine.
Because what I did. Yeah, that's what I did.
Yeah.
I just did it in a different way.
You might have been able to plug in your calculator for permutation 2 divided by 14 permutation 3, and it gives you whatever that decimal is.
I just did it, this is okay, I just did it separately. I did like the top portion and I got 12, and then I did the denominator and I got 2,184, and then I just divided it.
12 divided by, yeah, so it's just simplified here. Here, I actually never did any calculations until the very end, and at the very end, all I had to do was do 14 times 13, where it doesn't really matter what step. Maybe the 12 didn't cancel, but here I can see, since it's kind of in factored form, I reduce it faster because it's easier to reduce versus taking 12 times 13 times 14. I don't really necessarily know what's going to simplify easier. But yeah, you should know the formula, because I might ask for just the formula. What is the formula for a permutation? How do you calculate it? You take n factorial divided by n minus r factorial.
That's all of us.
Right, so the formula is important. And here what's really going in is that if I have n objects and I want to group, or I want to take r of them, it's the same as taking n times n minus 1 times n minus 2 all the way down to n minus r. This is what it's saying. The numerator, you divide out n minus r factorial from n factorial. Right? Did anyone have any questions on those? So there's not going to be, this is the very beginning of chapter 11. So there's not going to be a lot of just plug it in your calculator, tell me a number. It's going to be an application to a word type problem. And we can see some of those. We see here, how many website graphics can be created by using at least 3 of 5 different bitmap images? So a bit about a bitmap image. The order would matter as far as the image, right? So order matters here. So this is a permutation. We haven't learned anything else. So at this point, it's a little like, yeah, okay, that's all I know how to do. So this is going to be 5 permutation 3, at least 3, plus 5 permutation 4, plus 5 permutation 5. Like I said back in chapter 2, the word at least and at most is going to come up throughout this book. What it means is that, at least 3. That means you're using 3 or more. So if there's only 5 of them, you can use 3, you can use 4, or you can use all 5. So on number 37 there, you go to calculate 5 permutation 3 plus 5 permutation 4 plus 5 permutation 5. Does that make sense there? If it said using exactly 3, it'd be 5 permutation 3. But at least 3 of them, 5 permutation 3 plus 5 permutation 4 plus 5 permutation 5. Any questions on that?
How do we know when to use like addition?
Anytime it's talking about separate cases, at least and at most in this chapter is going to be a good, it says at most 3, you would do 5 permutation 0 plus 5 permutation 1 plus 5 permutation 2 plus 5 permutation 3. But if it says, how many ways can I rearrange 3 images out of 5, that's just 5 permutation 3. So the wording, yeah. Let's look at number 49. We have a panel of politic form consisting of 4 Democratic, 5 Republicans, and 3 Independents. How many different orders can be seated if all that matters is party, not individual?
What does that mean?
So it's saying groups, like you're an individual person and someone else is an individual person, but we don't care that you're only Democrat, you're red, blue, green. So anyone from the red group is going to be the same group. In a sense, it's going to be kind of the same pool as someone from the green group.
So the color, as far as labeling it.
Yeah, as far as saying, what's a different group? What are we pulling from? How many options do we have? So in how many orders can they be seated if all that matters is party? So if I have 4,
There's 3 parties.
Democrats, Republicans, and Independents. So, but I'm looking for a panel of how many is on the panel? 4 Republicans, Independents, and how many orders can they be seated if all that matters is party, not individual?
Like 4 exclamation point plus 5 exclamation point plus 3 exclamation.
It's kind of thinking like pants, shirts, hats, right? So how many orders can be seated if all that matters is party, not individual? So this is a little ambiguous because you don't really know how many people are on this panel.
Right.
I'm guessing how many orders can they be seated if all that matters is
4 Democrats meant like 4 people and 5 Republicans meant 5 people.
Yes.
Is that your panel?
Yes.
Yeah.
So that'd be
That's
12.
12.
So you have
That's the right
12
answer.
people. So on the panel, oh, okay. The panel consists of 12 people.
Yeah.
Okay.
That's
Gotcha.
what I just kind of guessed.
Yeah, no, that's what I'm saying. The panel consists of 12 people. They make up 4 Democrats, 5 Republicans, and 3 Independents. So there's going to be 12 spots to sit them.
Is that where we would go 12 factorial divided by 4 factorial, 5 factorial, 3 factorial?
Yeah. So these are the repeats,
Okay.
right?
Like
So
we
it's
did
just like Mississippi,
Okay.
right? So yeah. So I have 12 spots to sit them. It's kind of like my roster, but I want to say instead of looking at each individual person, the Republicans are all red. So I only see dots. I see red, I see blue, or I see green. So it's just like Mississippi in that sense. So yeah, you're going to have 12 factorial divided by 4 factorial, 4 factorial, 5 factorial, and 3 factorial. Because those are going to be the repeats of all the blue people, or the red people, or all the green people.
Okay.
Yeah, so the wording on this one, a little bit different, but the application's just like the word Mississippi.
So the next one might be the same way, but we're talking about a roster.
Yeah, so the active roster, so kind of the same sense, we're going to have how many choices does a manager have for batting order? List the 9 starters from 1 to 9. So out of 25 people, you only have 9 spots. So versus 25 people, you have 25 spots, that would be 25 factorial. But here, this is going to be
So 9 factorial.
25 permutation 9, which would be the same as 25 times 24 times 23 times 22 times 21 times 20. 1, 2, 3, 4, 5, 6. Basically, you're gonna have 9 spots. You have 25 choices for number 1, right? You're gonna have to put these in order from 1 to 9. You have 25 people on your roster. That's gonna be 25 permutation 9, or 25 times 24 times 23 times 22 times 21, all the way down to 9. Which is the same as 25 factorial over 25 minus 9 factorial, which is 25 factorial over 17 factorial, which is this. Huh? Yeah, it's a large number. How many different combinations you
And
have?
then when we have that really large number, do you want us to go ahead and like batch it out, like move the decimal?
Is it in scientific notation?
Yeah.
You can leave it in scientific notation if you do it correctly. So if your calculator says 1.729 times 10 to the 13th, that's fine. Some calculators are going to truncate. When you get really large numbers, they're gonna cut it off at a certain, they don't have that many places in the calculator to hold it. So
I just wondered, can I like watch the online
Mhm.
ones that you put on there?
Mhm.
And she does want us to like go ahead and
yeah,
let me know.
I'm not going to be picky about it. If you get that number because you're plugging the right combination buttons in your calculator, then it's going to be the same number. If you have 8 zeros behind it, or if you have 10 times the 8, it's saying the same thing. Does anyone else have any other questions on 2.1? 11.1, sorry, back in chapter 2. 11.1. Okay, I think it would be kind of beneficial if we stay a little bit ahead of the schedule. That gives us some flexibility. So I want to go ahead and introduce a little bit of 11.2 with you guys. So
Full steam ahead.
that's right. Oh, I hate it when it gives it to me like this. Okay, so in 11.2 we talk about combinatorics, right? Another fancy way of just saying it's a method of counting. So we're going to learn the combination formula, which is very, very similar to the permutation formula, except with combination, order doesn't matter, right? So if I say I'm picking 3 people to be on a committee, it's a combination. If I say I'm picking a president, vice president, and a secretary, that's a permutation. So if order matters the way I pick them, your president, your vice president, your secretary, that's going to be a different group if the order is different. So half the battle on these types of problems are going to be to identify, is this a combination or is this a permutation, and then plugging it in the right formula to get that out. So we're going to look at the number of combinations of n objects taken r at a time. So repetition is not allowed in combinations or with permutations. If there's repetition is possible, you kind of have to do the fundamental counting method, right? If I have a 4-digit number and I can repeat them, then it's going to be 10 times 10 times 10 times 10. You're not going to be able to use a combination or a permutation on that. So there's going to be like 3 categories we look at. So if it says with repeats, do not think permutations or combinations, because permutation and combinations both have to do with once you use the object, you can't use it again. Or once you pick the object, you can't pick it again. And then use a combination rule with injunction with the fundamental counting principle. So we might have to say, you know, we have X amount of blue balls, X amount of red balls, X amount of green balls. If I want to say how many different combinations can I get, I might have to talk about 3 different categories. So we kind of use that fundamental counting principle idea where we have 3 lines, but instead of putting a number in the line, we're going to put a combination formula. So a combination is a selection of objects without regards to order. So it's kind of backwards for a lot of people. They think combination order matters, right? You think combination lock. You got to put it in the right order, but that's not what you want to think about it. Combination, the order doesn't matter. So here's an example. Given housemates Ruth, Elaine, I don't even know how to say her name, and Jasmine, list the permutations and combinations when you're selecting 2 of them. So here it says what's the permutation and what's the combination. And I haven't gone over the formula yet. So let's go back to the combination formula. And this will come up on your guys's notes. But in combination R, it's going to be n factorial divided by n minus r factorial divided by r factorial. So if you notice, this is the same as a permutation, right? Except the only thing you're going to do is you're going to divide out by the repeats, and the repeats are going to be r factorial. So permutations always have a larger number than combinations. Right? So you're going to take the permutations and really divide out by the repeats. You guys see this, what's going on here?
Isn't that how it was with Mississippi?
Well, Mississippi, we had like objects, and we're rearranging them all in, we're using all of them, right? So the example of those 12 Democratic Republicans, we're using all 12 of them, right? So we're using them all. So we have to divide out by like objects. It's kind of along that line where if I have, if order doesn't matter here, then it doesn't, if I pick 3 people to be on a committee, I have to divide out when I pick 1, 2, 3, 2, 1, 3, 3, 1, 2, 2, 3, 1. There's all, these are the exact same group of people, but they're different order. A permutation is going to take all of them in account. And there's actually 6 different ways I could rearrange them, which would actually be 3 factorial. So if I'm taking 3 of them, I'm going to have to divide out by 3 factorial. If I'm taking 4 of them, I have to divide out by 4 factorial because I don't want to count all these 6 times. I only want to count 1 group. This is the exact same group. If I was to arrange you guys in groups and not give you guys titles, group 1, 2, 3 is the same as 2, 1, 3. But if I would have said this is the president, this is the vice president, and this is secretary, all these are different groups. So if order matters, it's a permutation, and if order does not matter, it's a combination. And we can calculate it in this manner. What they're trying to get on this example, what they're trying to get you to do is you have 4 different housemates and you want to list the permutations or the number of permutations, the number of combinations. They start by making a list. Okay, we don't want to do this because we're going to get really long lists, but getting us to that formula, permutations, if I'm picking 2 of them out of 4, right, I can pick all the ones I have here. So what is 4 permutation 2? 4 permutation 2 is 4 factorial over 2 factorial, which is 4 times 3 times 2 factorial, which is 12. And you can see they listed out 12 different combinations or permutations. Out of those 12, I want to take out the repeats. So Ruth and Elena and Ruth, so I had to take out one of those because they're the exact same group. You guys see that? So I'm actually only getting 1, 2, 3, 4, 5, 6. But you can see if I divide this again by 2 factorial, I get 6. Right? This is a long way to kind of show you the formula. There's 12 permutations. There's going to be 6 combinations. So if I was to do 4 combination 2, that's 4 factorial over 4 minus 2 factorial times 2 factorial, which is 4 factorial divided by 2 factorial times 2 factorial. Don't take 2 factorial and 2 factorial and get 4 factorial. 2 factorial and 2 factorial is actually only 4, not 4 factorial. Sometimes students will get in trouble with doing that. They have 4 factorial over 4, which is, if you plug this in your calculator, you get 6, which is 3 times 2 times 1.
Where did you get the 2?
This 2?
Yes.
That's the R in the formula. So remember the formula we said in combination R is n factorial over n minus R factorial times R factorial. This is extra when you're talking about a combination. You have to divide out by the repeats, and the repeats are going to be R factorial.
How did you get R equal to?
Because we know we're taking them 2 at a time.
Oh,
There's 4 housemates, and we're grouping them into groups of 2. How many different groups do we have?
oh, by selecting 2.
Yes.
Okay.
R's the 2. So I have 4, and I'm taking them 2 at a time. In a permutation, I'm going to have 12 different options. But not everything works out to be a permutation. Some things are combinations. Because if I pick the same 2 housemates, that's the exact same group. It doesn't matter what order I pick them. Makes sense? Question.
When you multiply a factorial by a factorial, does it cancel out?
When you multiply a factorial by a
Because you got 4
factorial.
factorial.
No,
factorial
it
over
doesn't.
4.
It's because 2 factorial is 2.
Oh, okay.
That's the only reason. If you had 3 factorial times 3 factorial, it would not be 6.
Okay.
Or would not be 9. It would be 12 actually. Because 3 factorial is 6 and 3 factorial is 6, and that multiplies together to be, yeah. So be careful with that. 2 factorial times 2 factorial is 2 times 2, which is 4. 3 factorial times 3 factorial would be 6 times 6, which is 12. Does not equal 9. The factorials don't cancel. So in this example, we're only determining if it's a permutation or a combination, because that's going to be your first step on these problems. Once you then know it's a permutation, use a permutation formula. If you know it's a combination, use the combination formula. From a class of 25 students, a group of 5 is chosen to give a presentation. A combination or a permutation?
What should be ordered?
Is order important?
No.
Right, because everyone's given a presentation. It doesn't matter who goes first or who goes. If I'm going to pick 5 of you to give a presentation today, it doesn't matter who goes first or who goes last, right? So order doesn't matter, so it's a combination, right? If I would have said, first person gets an A, second person gets a B, third person gets a C, then order is going to matter there. So it's a permutation. A starting pitcher and catcher are picked from a 12-person intramural softball team. So basically I'm picking 2 people. The first one's going to be the starting pitcher and the second one's going to be the catcher. It's a permutation, right? Because the order matters. It's different. It's a different group. It's a different
You don't want to be
outcome.
last.
You don't want to be last. It's a distinct position. So that might be kind of something to highlight it. If it's grouped into distinct positions, it's going to probably end up being a permutation. If it's just general, then it's going to end up probably being a combination. Is it starting to kind of make sense, the different approaches? So this is just a combination rule we talked about. This is the formula. This formula is taking n objects r at a time, and order does not matter. So you guys all have a combination and permutation buttons in your calculator if you haven't found them yet. This is the combination button. So if you identify the problem as this is a combination problem and I'm taking 5 objects and I'm grouping them into 2, that's going to be a different number if it's a combination than if it's a permutation. But if you want to calculate it by hand, this is the formula. So example 3, how many combinations of 4 objects are there taken 2 at a time? Yeah, 4 combination 2. 6, right? It's the same one as we did before. 4 factorial over 4 minus 2 factorial times 2 factorial, which is 4 factorial over 2 factorial times 2 factorial, which is 4 times, there's different ways you can end up writing it. Maybe I'll write it 4 times 3 times 2 factorial over 2 factorial times 2 factorial. I get 12 over 2 factorial, which is 6. The way you plug it in your calculator is important. You plug it in at this point. You want to plug in 4 factorial divided by open parenthesis 2 factorial times 2 factorial close parenthesis. You will get a different answer if you plug in 4 factorial divided by 2 factorial times 2 factorial. All right? Because your calculator is going to do order of operations. You're going to do division. They're going to divide this, and then they're going to multiply 2 factorial. So if you want to plug it in at this point, it's fine, but you need to plug it in open parenthesis, close parenthesis on everything that's in the denominator. If you want to just play around with your calculator and input these both ways, you're going to get 2 different numbers. You'll get 6 here, and here you'll get 12 times 2, you'll get 24. 24 is not the answer. But you're going to also have that combination button to kind of check yourself. And go through to kind of So by studying abroad one semester, Tran is required to visit 10 different cities. He plans to visit 3 of the 10 over a long weekend. How many different ways can he choose the 3 to visit? Assume distance isn't a factor. So here, yeah, it's a combination. The first thing to know, it's a combination because order doesn't matter. It doesn't matter what order he visits the cities in. He gets to check those 3 off his list, right? So what would I write?
10 combination 3.
Yeah, 10 combination 3. Which is 10 factorial divided by 10 minus 3 factorial times 3 factorial, which is 10 times 9 times 8 times 7 factorial over 7 factorial times 3 factorial, which is 10 times 9 times 8 over 3 factorial, which is 10 times 9 times 8 over 6. Which I could do some algebra. No, this is 2, this is 3, this is 5. 15 times 8. Would be 8, 19, 11, 12, 120. Or you can plug in your calculator. So if what I did there confused you, ignore it. It's just math, algebra. But you should be able to plug it in really at any point and get 120. So there's 120 different combinations of picking 3 cities from 10. So. Number 5, at one school, the student government consists of 7 women and 5 men. How many different committees can be chosen with 3 women and 2 men? So this is kind of that fundamental counting principle, right? I have 2 groups. I want my women in this group, and I want my men in this group, right? I want 3 women and 2 men to be on my committee. So I need to know how many different, out of 7 women, I'm picking 3 of them, right? How many different ways can I pick 3 from 7? That's how I'm going to get my 3 women. How many different ways can I pick 2 from 5? So these problems seem kind of complicated because there's kind of a lot going there, but if you simplify it into what are we talking about here? We're talking about men, we're talking about women. How many different combinations can I get of 3 women? How many different combinations can I get of 2 men? If I add those 2 together, I have 3 women and 2 men. Question.
So basically, you're just doing 2 different problems.
You're kind of doing 2 different problems, yeah. You're doing, I have 5 pants and I have 2 hats, and I want to know how many outfits I have with hats and pants. I would take 5 times 2, right? So it's going to be the exact same idea, but we don't know how many pants we have at this point. So how many different groups of 3 women, different groups, can I get when I have 7? So I have 7 choose 3 because order doesn't matter, plus the 5 choose 2. Yeah, so this is kind of that fundamental counting principle of breaking it down into different groups. Does that make sense? So 7 choose 3 ends up being 35, and 5 choose 2 is 10. So this is 35, and this is 10, and it's not plus.
Oh.
Yeah, right. Remember the fundamental counting principle? If there's K ways, K1 ways to do one thing and K2 ways to do another, we multiply them. The at least and at most, that's where you're going to add.
So can you just enter it in like?
You should be able to enter 7, choose 3 times 5, choose 2, enter, and get 350.
So what did you say? At most?
The at most and at least, that's where you're going to add. But if it said, you know, how many different combinations of at least 3 women, you would have this number when you have 3 women. Then you would have to do 7 choose 4 times 5 choose 1. And then you would have to do 7 choose 5 times 5 choose 0 and have 3 different numbers, and that's where you would add them. This, anytime you're thinking of horizontal and vertically, anytime you go horizontal, you're going to multiply. Anytime you go vertically, you're going to add. That's going to come up when we get to tree diagrams. It's going to make more sense when we get to probability and tree diagrams. If you multiply the branches, if you look at the branches, you're always going to multiply, but when you add down, they're always going to add up to 1. Because anytime we talk about probability, all the different outcomes are going to add up to 1. And all this is going to, the more experience, the more we get into chapter 11, I think the more it's going to click. Right now, I'm just trying to give you a glimpse of it, and then there's a lot of stuff that else can happen. So once I show you everything, it starts making sense why we do it a certain way. Yeah, so this is kind of like how many pairs of pants I have and how many hats I have. So I have 350 total outfits. Make sense? Designing a calendar. So to raise money for a charity event, a sorority plans to sell a calendar featuring tasteful pictures of some of the more attractive professors on campus. Right?
Awkward.
Yeah. They will need to choose 6 models from a pool of finalists that include 9 women and 6 men. How many possible choices are there if they want to feature at least 4 women? There's that at least again, right? At least 4 means 4 or more, right? I'm choosing 6. So I have to find the number of ways to get 4 women and 2 men. plus the number of ways to get 5 women and 1 man, plus the number of ways to get 6 women and 0 men. Right? 4, 5, and 6. Really, I kind of should have wrote it like this. Yeah. Just, we're adding in this case because this is different groups. But within the different group, how many ways can I get 4 women and 2 men? Well, how many women do I have to choose from? So I go 9, choose 4, times, how many men do I have to choose from?
6.
And I want 2 of them, right? So 9, choose 4, times 6, choose 2 is going to give me how many different ways to get 4 women and 2 men? Then 9, choose 5, times 6, choose 1, and 9, choose 6, times 6, choose 0. So it's basically doing the same thing we did in example 5, but we're doing it 3 different times, and then we're going to add those numbers together. Right? So you see why that combination and permutation button in your calculator comes handy. You're not going to have to calculate each one of these by hand. Just plug that in your calculator. So what's 9 combination 4?
I just did the whole thing out and it said.
Okay, so I can go through here. 4 women and 2 men, 9 combination 4 times 6 combination 2. They get 1,890. Then we have to do the 5 women and 1 man. We get that many ways. And then the 6 women and 0 men, we get that many ways. And so if we add up those 3 ways, we get 2,730. The same principle, except it uses that at least or at most. So I have to talk about how many categories I have there. Then we add this up. Then you add them up and come up with 2,730. So the fundamental counting principle comes in here. And then the at least and at most talks about different groups of, and you're going to add those. So you multiply within the category, and then you add the different categories.
Where does the 9 come in?
The 9 is the number of women we have total. The number of women we have to choose from. So when I look at these problems, I highlight or I kind of circle the key things. I know I have 9 women and I have 6 men. I need 6 models and I want at least 4 women. So I need 4 women, 5 women, or 6 women. How many women do I have to choose from? 9. How many men do I have to choose from? 6. So all these numbers here are going to be 9 and all these numbers here are going to be 6 because that's my pool. And then each individual case is going to be 4, 5, or 6, or 2, 1, or 0, depending on how many men I want. These 2 numbers here have to add up to 6 because I'm picking 6 people. So if I want 5 women, I want 1 man. If I want 6 women, I want 0 men. If I want 4 women, I want 2 men because I know they have to add up to 6. Does that make sense?
Yeah, it's a lot to see at once.
It's kind of a lot to see at once when you haven't been exposed to a lot of the times, but you'll start to see, okay, this is important. The rest is just fluff. And sometimes that gets frustrating to kind of read between the fluff. But once you read it, to be able to highlight, okay, I need to know how many men I have, how many women I have, how many models I need, how many do I want to be women, how many do I want to be men to satisfy the condition at least 4 of them are women. So 4, 5, or 6, and then kind of go from there. So work here is very important because if you come up with a number and that's all you give me and it's wrong, you don't have a hope. right? On this would be a, 12, 13 point problem. I want to see it broken down a little bit more. So the work is important there. So we went through and looked at those categories. Let's pull up some of the homework. So we look at, what did I assign you guys?
A lot.
5 through 45? 45, every other on. So
Just kidding.
5 is just kind of coming up with different situations. Describe a situation where counting would be required. Both the combination formula and the fundamental counting principle, those are like the last two examples we talked about, 5 and 6. The fundamental counting principle is when you're going to have kind of different categories, men, women, cats, dogs,
Apples and oranges.
apples and oranges. The first couple ones are just kind of writing exercises. You should be able to answer any of those or be able to make the connection on any of those. The 9 through 13 are all just, can you plug them in your calculator or can you write out the formula? Now on the exam, I might say use the formula. If it's a problem like this, I want to know, can you use the formula? But if it's in a multi-set problem, I'm going to assume you're just going to plug it in your calculator. So if it says use the formula, plug it in the formula, right? So if it says use the formula here, 5 combination 2, you have 5 factorial over 5 minus 2 factorial times 2 factorial.
Will you ever put the formula on the?
I might ask, what is a formula? So you need to know it.
If you do that, can we just write it out like that in the formula and then put it in our calculator?
Yeah, so you guys will have your calculators for the exam, so of course, yeah.
That would be the minimum we would need to know.
Yeah, this would be the minimum I would want to see
Full credit.
to get full credit. Then of course you're going to be able to plug it in your calculator. And you can go a little further, right? Because you have your calculator as backup. It's going to be able to tell you your answer. So you can go a little further here and say 5 times 4 times 3 factorial over 3 factorial times 2 factorial. This might just be easier to see. Is 10. If you plug in your calculator, you get something other than 10, you might recheck that, and then you make sure that you understand how to get that. Or if you made a small error here, and your calculator gives you something else, you might go back and check your algebra. But yeah, this is the minimum. More than likely, I will just say what's in permutation R. Then you just, doesn't mean anything except plugging in the formula.
So on 13, it would be 6 factorial over 6 minus 4 in parentheses factorial times 4 factorial.
Yes. Which would be 6 times 5 times 4 times 3, 6 minus 4 times 2 factorial over 4 factorial times 2 factorial. You should write that differently. 2 factorial. Now here I can cancel the 4 factorial and have 30 over 2, which is 15. But again, you should be able to plug that in calculator confidently enough and get the same answer.
Do you happen to post these on Blackboard?
The
Screenshots
screenshots of what this is right here
of the homework?
of the homework. I posted chapter 2 just so everyone would have a chance to get into the book. Of course, it's being recorded, but if you need them, send me an email and I can decide that. I did it one semester and then everyone sold their book back, and so I don't know if that's
I understand why you would do that.
yeah, and it's copyright issues and stuff, but I always just use them to present the material. So. But if I screenshotted everything and put it on there, I might get in trouble from the publisher.
Ms. Van Dyke,
Yes.
I just looked at the one that you just had up there.
Yes. Did I do something crazy?
How did you cross out the 4 and the 3?
I crossed out the 4, the 3, and the 2 factorial because 4 factorial is 4, 3, 2, 1. This is 4 factorial, really. This is 4 factorial. And I canceled the 4
Oh,
factorial,
canceled, okay,
which is
got it.
4 times 3 times 2 factorial.
okay. I did it the other way.
And that's perfectly fine. You can cancel out the 2 factorial
Yeah.
and you have 5/4,
Yeah, which
6, 5,
takes
4,
longer.
which is, yeah, but it's still, it's going to get you to the right answer, which in the end is what matters. Right. Don't be intimidated by some of these.
Yeah.
They're just plugging in your calculator. Now, question?
Should we separate that or just do like the whole numerator in the calculator and then parentheses the whole denominator?
I like numbers.
You
Yeah,
can do that. You
whatever
can
you
actually
want.
put it
Yeah,
in
I
all
like
one
numbers a
line.
lot.
Open parentheses, 10, combination 3 times 6, combination 2, close parentheses, divided by 6, combination, open parentheses. Parentheses are important to tell your calculator, this is all in the numerator, divided by this is all in the denominator. Because if you don't put in your parentheses, it's gonna times, divide, time. And you don't want that.
Right.
And we'll look at some more word problems, but more exposure is going to give you guys, oh, this is just like the, 9 women and 6 men, and I want at least 4 of them women. It's going to be kind of the same type of problem.
It'll essentially look at the pattern there.
Yeah, you'll kind of be able to see the pattern, and then you won't have to read through all the fluff and just get down and answer the question.
Yeah.
All right, I'll see you guys on Wednesday.